Hey friends, welcome to my channel. Let's have a look at problem 2131, longest palindrome by concatenating two-letter words. In this video, we're going to share a solution based on simple counting. And actually, the logic for this problem is very straightforward, and the code can be very short. First, I'll read through the statement to digest the problem requirement, and then we do a detailed analysis, and finally we share the short code. First, let's look at the statement. We are given an array of strings called words. Each element of words consists of two lowercase English letters. So we want to create the longest possible palindrome by selecting some elements from the list and concatenating them together. So each element can be selected at most once. So we are required to return the length of the longest palindrome we can create. So notice that the longest palindrome is not unique, but the maximum length is unique. So if it's impossible to create any palindrome, so we're going to return 0. So here are 3 examples. So the output are 6, 8, 2 respectively, so which can be interpreted from the explanations easily. We're not going to go over the examples here, as we want to do some refined analysis after a while. So before we do the analysis, let's look at the constraint. First, the list of words is not empty, and its length is bounded above by 10 to the power 5. So 10 to the power 5 actually is a decent large number, which gives us a upper bound for this problem size. And each word actually has a length 2 and consists of lowercase English letters. With that said, I guess we are ready to transition to explaining the idea. So as we mentioned, so the idea actually is very simple. So we just do simple counting. So we distinguish between words with repeated character like AA or without repeated character like AB, and we count how many words of each kind we could use to form palindrome, right? So the procedure is as follows. So we are writing in terms of a algorithm format. So first, we want to make a word frequency dictionary out of this word, and then in step 1, so what we're going to do is to find the frequency list for word with repeated character. So for example, let's call this list array. Then the number of such words can be used is counted as follows. So here actually overall is like this. So we are going to use up all of the even part of their frequencies, and then if there were odd frequencies, so we're going to use one additional pair. So in coding format, so we can initialize a variable with 0, and then we flag variable to test if there are odd frequencies. So for y in this array, so if y is even, so we just count this number of words, and if it's odd, so we found that there is odd frequency counting, and then we increment the can use by the even part, that is y minus 1, and then overall we check flag. If flag is true, so we use an additional pair. So this is the counting for the use of word with repeated character. So for words without repeated character, so we need to match each occurrence of word with its reverse, right? So the counting for such case is very simple. So we can initialize a can use, and then for word in the dictionary case, so we increment the can use by mean of count words with the count of its reverse. If the reverse does not exist, we are going to set it to be 0. So because each time if we use one word, we use its reverse, so we can't make this times by 2. However, so for this way, we iterate over the dictionary case, we count twice if both word and word reverse appear in the dictionary. So we need to divide afterwards by 2. So here multiply by 2 and overall divided by 2. So the overall effect actually is like this. So can use is 0, and then we just for word in count, so we can use is this, right? For word without a repeated character, right? So this is the algorithm level. So the step 2 I would say is the return. So can use plus the 2 count, then multiply by 2, right? So this is the return. So here is an example, right? So here in this example, NN appears false and HH appears once. This is an odd count. And then HJ and GH appears once each. So we can use 4 NN and 1 HH, and then 1 HJ and 1 GH. So the return is 14, right? Because 7 words are used. So one palindrome can be like this, right? So for example, you can change HJ and GH, so it's still a palindrome. Or you can move HJ in between this pair and move this HJ in between this pair, and so on. So in other words, the palindrome with maximum length is not unique. So with that said, I guess we are ready to write the code. So the code actually is very straightforward. So but we are going to write with some redundancy for fixing the ideas. So first we make a word frequency dictionary, right? So this is very simple. So let's call it count. So collections counter, right? So out of these words, and then we are to do the counting, right? Do simple counting. So for this, I'm going to distinguish, right? Can use repeated with repeated characters. So let's say 0, and can use non-repeated words. The words with not repeated characters is also 0. And I'm going to initialize a flag. So let's put this flag here, because this flag is to check if there are out-frequent count for words with repeated character. So because this flag is associated with this one, I put it in the same line. And then I'm going to iterate over the dictionary. So for word frequency in count items, right? Then we're going to check if word is repeated or not with repeated words. If this is the case, what we're going to do is that, so we check the frequency. If the frequency is even, right, so we just add this, use all of them, so increment by y. Otherwise, so the frequency is odd, so we're going to use even number of them, so that is y minus 1. But in this case, we also know we meet a frequent count without counting, right? So we're going to set its flag to be true. So this is for word with repeated characters, and otherwise, so word without repeated characters. So we can do this. Can use non-repeated. So we are going to increment by min of count to this word, and then we're going to get count, right, word reverse, and if does not exist, with 0, right? And actually we need to multiply by 2 and divide it by 2 as explained above, but we just keep this short format. So actually, in order to get the number of words used without repeated character, we can just use a list comprehension, but you know, it's suited in this case. In the else, we write it here. So then before we do the return, let's do not forget to check the flag. So if this is the case, we're going to can use with repeated character, so it's incremented by 1. We can use 1 additional words. So this is the 2 steps, and then we're going to do the return. So the return is straightforward now. So we can use this one, copy this one, and then copy this one, So this is the number of words that can be used in the maximum length palindrome. Then we need to multiply by 2 because each word has length 2. So this actually forms a format of solution for this daily challenge problem. So now let's do a check. So y is not defined, so I see. So here is the frequency. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the test cases. Actually, in my first try, so I actually forgot to multiply by 2. So, the return is not right. So with that said, I guess that's about it for this specific problem, and also it's about it for this video. So you are welcome to check out other problem analysis in my channel, and if you have comments or suggestions, that will be good to share at the video. With that said, that's it for this video. Thank you.